Hey there, it's me Usama, and I'm here for the final year project working demo video. And the title of our project is Unnamed Ground Vehicle for Security Surveillance Purposes. So actually what our project mainly is, let me just give you a brief idea of our project. Is that there will be a robot which will be available there in the buildings or in the any sort of defined premises for security surveillance application. What actually it does is that it will detect the crime, capture the scene of the crime, and then it will send back it to the user for security purpose and in safety of the premises. So let's move on. Okay, so we got our project supervisor here, Assistant Professor Dr. Mohammad Tufail. My project fellows is Hamad Ahmed and Shafiq Ahmed, and myself is Osama. So moving on to the project workflow of the code, is that what will actually happen in the code is that the frames will be firstly extracted from the video which the camera captures while patrolling or surveillance in the premises of a building, and then this frame will be forwarded towards CNN, which is usually known as Convolutional Neural Networks, for the further features extraction and the building of the model. And then these things will be forwarded further to LSTM, which is known as long short-term memory, for further feature extraction. And then at the end, the model built it or trained upon these two algorithms, CNN and LSTM, will be able to classify whether it is a fight or it is not a fight, or whether it is a violence video or a violent scene or not a violent scene. So let's just move on and just explain these two algorithms and the frame extraction architecture which we got from CNN in the next slide. Okay, so the most important thing in any machine learning process or code is that first we have to got a data set. So in this video or in this code, the data set we got are hockey data set and movies data set, the links of which will be provided further in the video description in the progress report as well. So now moving on to feature extraction, the architecture we used is VGG19, which is a lot similar to VGG16, irrespective of the layers it got. VGG16 got 16 layers and VGG19 got 19 layers in it. So what actually it does, that it inputs the image of 2 to 4 cross 2 to 24 pixels. The three mean that these are three images actually, R, G and B. And then what actually it does is that it gives the convolutional plus the ReLU function, which actually outputs the output if it is positive, and it drops the output to 0 if it is negative. And then we got the max pooling, but in our code we got global average pooling, and then the fully connected layers of the ReLU function, and then at the end we got softmax. So what actually softmax do is that it is a squashing function that limits the output in between the range of zeros and ones, not outside that, not inside that. So actually what happened there is that the video we have provided for training, or the video we will provide for the surveillance, will get extracted, features will get extracted by the CNN architecture VGG19, and these will be done by max pooling and ReLU functions and softmax, etc. And then these features will be forwarded to two of the mostly known algorithms as convolutional neural network CNN and long short-term memory LSTM. So what actually CNN does is that it acts upon two features. It will extract spatio-temporal features. What does the spatio mean is that they will extract the features from the actions from each and every frame, and then they will analyze the what's going on in the frame. What actually the temporal part will do is that it will get the connectivity between two frames, that what is actually the difference between the actions in the previous frame, in the next frame, and then consequently in each and every frame. And then these features will be forwarded to LSTM, the long short-term memory algorithm. And what actually this algorithm does is that it have memory gates to save the necessary information and ignore the unnecessary information. So what actually it does is that it will construct or get some of the extract features from the previous frame, and then it will get the features from the another frame, and then it will create a connectivity between these two frames, and it will forward it to the model. And these the model we have built on basis of these two algorithms, CNN and LSTM, is a custom-made model which is known as VD model, known as violence detection model. And these models will then get the video we have provided in the path, and then it will be analysis further analyzed in the in the video, in the code, that whether it is a fight or not fight, and what is the estimation of the violence or not violence. So let's move on to the code, and we will then know that what each and every snippet mean and what is the function of it. Thank you so much. So now welcome to the coding part, and this is our folder, the file directory in which our videos and the fight weights and each and every code for our model building, model detection, and the actual code is present here. Now I've opened these two codes. The first is our violence model, in which we have made our model, and then we have run our model for model building. So these are all the imports which are necessary for the violence detection, like each and everything with image processing and detection, CNN and LSTM we got these from these libraries, mostly TensorFlow and NumPy. Now we have this video reader function, which what will actually do is that we will provide the path, the video which we want to determine whether it is a violent video or a non-violent video. We will provide a video to this function, video reader. And what actually this function will do is that inside it have numpy operations, and each and every operation, the resize operation of frames that we want to reduce the pixel size, or we want to do any sort of numpy numerical Python operation in here, we will provide just the video file in here, and then the video reader function will do whatever we want to do in these predefined functions and methods. Now we have the actual model which we built as known as VD model, which is commonly known as violence detection model. The weights are defined in here, as we have defined the directory of fight weight.hdfs, which is actually a folder, a file over here. For that, the weights are predefined and predetermined, so we don't need to have a high computational power for determining the weights of the nodes in the CNN model. So here we have all the codes for the on the code for the model for CNN, which will actually build the violence detection model. And there is also the global average polling we have done in the start of the CNN model. We have the dense layer, the activation function, redo, the sigmoid, and the layers, etc. And then we have one function over here which will actually predict whether it is a fight or it is not a fight. We have defined the accuracy parameter, and then the model we have built, the model we have got by this model, which will be returned in the VD model, is tested being here, that whether if it is a violent video or a non-violent video. The last part of the code is that this function, which is actually a capture, which is not used up till now, but it will be used further in the actual robot, is that it will capture the video, and then it will determine whether it is a violent video or a violent action going on in front of the robot or not. So for now it is not being used, but it will be used in the future when we are actually applying it to the robot through a camera and a practical uses. So now let's just build this model to see what is the result of this. It will take some time, and there will be some errors because these type of errors, because I haven't a GPU in my computer, so that is a warning that the TensorFlow library might not function in some places, but actually it's good, there is no error. So we should move on, as these type of errors are not concerned with what I imported from Keras and TensorFlow. So now let's move on to the actual code of our violence detection. This is our actual code of the violence detection. Again, we have all the imports over here I needed from the libraries, and then now we have our model, the VD violence detection model over here. And then we have also the model summary over here, like how many layers, how many the polling we got, the nodes, and each and everything in the summary we have. And then we imported numpy for some numerical analysis. And then we have again the video reader function, which in which the function we will provide the video file, the path, and then the fight prediction, whether it's a fight or not, and then the main fight detection, main fight function, which will actually used whether the hockey data set I provided or the movie data set provided, whether it is a fight or not. So here you can see that if the F will be provided as violence or not, it is actually a boolean which will say true or not if fight is detected or not detected. So and now I have provided two videos actually. The one is no fight, which is present in my directory, and the one is fight.avi is actually a fight. So what we expect, we predict is that if the model reads this function, it will predict that it is a non-fight, non-violence video. The variable over here, the f, will be result as the violence will be resulted as false, and there will be violence estimation of it, a numerical value as well. And here what will actually the variable f does is that it will predict that it is a fighting video. There is a violence will be true, this flag will be true. So let's see the videos first, and then we will come back to the code to build it and see whether our predictions are true or not. So here is the fight.avi video, which is actually a boxing fight, a boxing scene. So actually these are actions, but these are actual the actions termed as the result as fights. So here we can see that these are also actions, but these are non-violent actions. So let's go to the model again and see what's the results. So let's build and run this model. Run. It will take some time. Again, the GPU type error, the information about the PC and everything, and this information is about the model, like the time distribution, LSTM, the dropout, dense layers, etc. Global average polling we used. Again, the video reading, the instruction and information about the pixel size, the RGB, red, green and blue. It shows the RGBs, that the image consists of three, or the frames consist of three RGBs, red, green and blue. Okay, so we got the results of our first video, which is a non-fight, a non-violent video, and here is the result that the violence is false. So this is the type of message, and this is the type of message that the violence estimation is very low. It's 0.0051% or a numerical value. This is the processing time we got. So this is the message which will be sent to the main robot through ROS, and this message will be termed as ROS topic, or which the this our node, the violence detection node, publishes to the main ROS robot, or the main file, or the main node, to determine whether to stop the robot or to let it move on again. And now at the end we have our last function, last result of the fighting video, which is actually a fight. So the violence variable, the boolean turned into true, that yes, it is a fight. So tell the robot or the node publish the information to the topic that it is a true fight, so stop the robot, which will be actually happen in the hardware project, which is our final year project in the